Hello, welcome to my presentation. My topic is creating novel non-periodic patterns for flat and curved surfaces from a single pentagonal element. My name is Anooshe Rezaee Javan and my co-authors are Ting-Uei and Yimin Ji. We are from Center for Innovative Structures and Materials of RMIT University, Melbourne, Australia. At the beginning of my presentation, I would start from a brief introduction about tessellation. Tessellation is the covering of a plane without any gaps or overlaps, using one or more geometric shapes, which are repeated over and over again. These figures show some examples of tessellations or tilings. The individual shapes in a tessellation are called as tiles. Tessellations are found in various times and cultures and are employed in many spheres of life, such as art and architecture. In the past decades, among many tessellation patterns, non-periodic tessellations have gained increased interest due to their interesting assembled forms. Nowadays, non-periodic tessellation inspires many modern architectural designs. These figures show two examples of building facades designed using non-periodic patterns. The Manuel Gonzalez Hospital in Mexico City is in the left and the Federation Square in Melbourne is in the right side of this slide. In this study, we presented a novel pentagonal element which is capable to create many continuous non-periodic configurations. However, it can easily be rearranged to form periodic tessellations. As can be seen in this figure, a perforated surface is created by the proposed single solid element. But, indeed, the base element of this identical element is a half hexagon with 5 equal length straight edges. There are many non-periodic tessellations can be formed using this single solid element. 3 examples have been shown in this figure. This study uses a shape transformation to generate the variants of a non-periodic pattern. As you can see in this figure, curved edges are introduced in the transformation process, which allow a variety of attractive shapes of holes to be formed in the non-periodic patterns. This figure shows a set of exciting configurations that share the same non-periodic pattern but possess different appearance. We have used the red pentagonal element shown in this figure to demonstrate that there are many other potential non-periodic patterns to form continuous configurations. One interesting thing, as shown in this figure, is that 9 different shapes of curved holes can be created in various patterns, while only a single element is used. In this study, also we have manufactured physical pentagonal component with the size of 320 mm by 170 mm using 22 layers of acrylic sheets and produce elements in hollow 3D forms. We have assembled a physical prototype using 18 identical 3D components as shown in this figure and built a non-periodic pattern to demonstrate its beauty and verify the manufacturing method. In the last step of this study, we have proposed a design method to reposition pentagonal elements for realizing curved surfaces using linearly translated of the element from the base plane to the target curved surface. It should be highlighted that gaps are inserted between pentagonal elements in the initial configuration to prevent clashes during the repositioning process. Manufacturing such curved surface from single pentagonal elements may include some challenges, and their connections need to consider for bending and twisting, which is currently under development. Without using connectors, installing support structures behind every pentagonal element to create a distance to the building profile is an effective strategy to rationalize curved profiles in facade applications, as shown in the right side of this figure. The conclusions from this study are: 1. The non-periodic patterns presented in this study can be used to create elegant architectural forms for practical application. 2. Manufacturing method to produce elements in hollow 3D forms using layers of planar components was proposed in this study so that recycling the offcuts minimize the waste. 3. A prototype of a non-periodic pattern was built in this study to demonstrate its beauty and verify the manufacturing method. 4. A target doubly curved surface can be rationalized using non-periodic patterns through a proposed repositioning method, which offers new design possibilities to construct complex curved surfaces from identical elements. Thank you very much for your attention. I would welcome any questions or suggestions.